Hello guys, my name is Naveen Kumar. I'm going to discuss the detailed solution for gate questions in mechanical engineering paper for year 2021. I'll be dealing the manufacturing part which belongs to section 4 in gate syllabus. So let's start the discussion. These questions are from set 1 that are like forenoon paper of mechanical engineering. The first question is, in a machining operation, if a tool traces the workpiece such that the directrix is perpendicular to the plane of the generatrix as shown in the figure, the surface generated is. So they're trying to ask what is the surface that is generated given a directrix of circle and a directrix of straight line. Okay, so before attempting this question, we have to know what is a generatrix and what is directrix. It's nothing but generatrix is the cutting motion. It represents the cutting motion. Okay, so let me write that. Generatrix represents the cutting motion. And directrix represents the feed motion. Right? Okay, feed is nothing but the distance traveled by the tool per mm of revolution, right? For a given revolution, for one revolution, how much is the motion of tool that is going, right? That is what is called feed in a simple turning operation. That's what I'm saying. Okay. So now here, what is given? Generatrix is given as circle. So let's denote this generatrix as G and directrix as T. Okay. So fine. So what is G that is given? G is in this question, G is given as what? Circle. We can see that it's a circle. And D is a straight line. Straight line. Right? Now, what is the surface generated? So how can you draw that? Simply, you put the circles, number of circles, you keep on replicating the circles in the directrix direction. Okay, fine. So let me draw that. So how do you do that? Put a circle like this, put a circle like this, put a circle like this, put a circle like this. You keep on put a circle in the direction of directrix, right? So this is the direction of directrix. At the end, what will you get? If you're looking that in a three-dimensional view, it's a cylinder, right? So how does a cylinder look like? So if you want to draw a clear diagram, so this is what is this. So this is the generatrix, that is what is G, and sorry. This is the directrix. D. So like this, we can say this is a cylinder. Fine. So the answer is B. For this question, the answer is B. Fine. So there are various generatrix and directrix. So we'll say some simple cases. Okay. So if G is generatrix, D is directrix, what is the surface obtained? What is surface obtained? If at all you have a generatrix as a straight line and directrix also straight line, let's say, for example, then the surface obtained, what is a straight line? Straight line generatrix G, and let's say directrix is perpendicular to this. Obviously, if it is not perpendicular, so it doesn't matter. Let's say it is perpendicular. So like this. So this is D. So what do? You generate G's in D direction, right? Like this. So what are this represented? It's representing a plane. So like this is plane. Okay. And if you're having generatrix as a circle and directrix as a straight line, obviously this is what the question has been asked, that is cylinder. Cylindrical surface. Okay. If at all you have circle and circle, it represents a torus, like a tube, right? Torus. So you have a simple, torus kind of thing, right? So it's a kind of a tube where circle is rotating in a circle. Generatrix is G and directrix is circle again. G and D both are circles. Like this, we can do so many take so many geometries for generatrix and directrix, and we can see what is the surface of plane. Okay, fine. Let's move on. Okay, so second question is in this manufacturing, that is the correct sequence of machining operation to be performed to finish a large diameter through hole is. Okay, fine. So what is the perfect sequence that is asking? Fine. So obviously the answer is here in a figure. I have put the figure here. First, the workpiece is here, and we don't have any thing that has been hold. And please make sure that you understand the through hole. Through hole is nothing but which is having completely the diameter, the hole has been passed from the workpiece. Like let's say this is your workpiece, and if we are making a hole, it is through. It means that it is starting from top surface and it is ending at bottom surface. So this is through hole. So what is a blind hole? Blind hole is nothing but it's like a hole which is not complete. It is not passed through the end. So this is your blind hole. So he's telling about a through hole, right? So what is through hole? It's nothing but you have a workpiece here, and you can start the drilling, and then happily it will be through the hole. And this is not a through hole, but it's a blind hole. But anyways, through hole is this. So our question is for this. It's not for blind hole. Okay, but anyways. So and next, what you have to do is that you have to enlarge it. So how do you enlarge? They enlarge by using a boring, bar. So you put that, and with this cutting tool here, as it is rotating, whatever the hole that you have made here will be enlarged by using this boring bar. After that, you can see that like you want the surface finish of the hole is not up to the mark. So what do? You go for the reaming operation. Okay, so the reaming operation will make the hole dimensionally more accurate, right? So reaming makes an existing hole dimensionally accurate. More accurate, I can say. Right? And of course, by making more dimensional, and also it improves the surface finish. Fine. So this is the order. One is you use the drilling operation. Two, use the boring operation. Three, use the reaming operation. Obviously, it's already clear. The answer is A. Okay, drilling, boring, and then reaming. And the tools that are used for drilling, boring, reaming are drill bit is used for drilling, boring bar is used for boring, reamer is used for reaming operations. Okay, fine. Let's move on. Okay, so in this question, again, they're trying to ask this question. In modern CNC machine tools, the backlash has been eliminated by. So previously, first we have to know what is backlash. Backlash is nothing but you have this lead screw, right? The lead screw are having some kind of gear mechanism. These are your involute profiles. Okay, and you have this nut that has been put here. Okay, Okay, so this is what is this, and like this. So this is your lead screw, and this is your nut. Right. So the gap between these two is your backlash. You can see here, this is your backlash. Fine. Okay. So this can be eliminated by what? So the answer is preloaded ball screws. So let's watch the video on what exactly is this preloaded ball screws. So let's see the video. Fine. So now that we have watched the video, you can clearly understand that those are the balls, or the screws. You can see here, the right. So these are the preloaded ball screws that are put here to avoid this kind of backlash between the nut and the screw, right? And if you are putting this kind of preloaded ball screws, what happens? The backlash in the CNC machine can be eliminated. So the answer is A. Okay, fine. Let's move on. Okay. The next question is, consider the surface roughness profile as shown in the figure, and he's asking the center line average roughness RA in micrometers of the measured length L is. So complete length is from here to L, and it is divided into 4 quarters, 1, 2, 3, 4, and this is the roughness profile. So we can find this by using two methods, right? So the one is you can use the formula like this. Okay, let's start. Let's see the diagram. Let me draw the diagram here. So if you are having some kind of a profile like this, so generally it is not like this profile. So surface roughness profile will be something, something like this. You have some ups and downs, right? Like this. So what is this? This is nothing but your mean line. Okay, and this is the length of which you're trying to measure, right? And this is the profile. So what do? You calculate the areas under this thing. So we calculate the areas. Calculate the areas. Right? Let's say this is A1, this is A2, this is A3, this is A4, this is A5. Okay. So the center line average formula is this. Center line average. The formula is, or you can say RA. Okay. Center line average roughness is summation of areas from I to whatever the n, summation of areas divided by the total length L. That is like A1 plus A2, plus A3 plus so on till AN divided by the length. Right? In this question, we have 4 areas, right? We have 4 areas. This is A1, A2, A3, and A4. Let's calculate the areas and divide it with the total length. And total length is L. Right? So let's do that. So what is center line average RA? Array is nothing but areas, total areas. What is the area? Area is, if you, the length is L by 4 into 1, right? This is 1, and then another area is L by 4 into, again it is 1 here. The distance is 1 here. So like this, we have how many? 1 into L by 4. Like that, how many we have? Into 4 we have, right? So divided by total length is L, right? This total length is, this is L. How much is this? It's 4 gets cancelled, L gets cancelled, and answer is 1. Okay, obviously he has given here in micrometers, so obviously we'll get here micrometers. So the answer is B, 1. It's a simple question. Okay, let's proceed. Next question. Till here we have attempted only 1 mark questions, like what are the things that we have seen till now are 1 mark questions, and this question is 2 mark question. Okay, fine. So let's read the question and carefully attempt the question. A true centrifugal casting operation needs to be performed horizontally to make copper tube section with outer diameter as 250 mm and inner diameter as 230 mm. Let's write what is given first. Okay, fine. Let's write. So what is given? Is saying the outer diameter. Let me denote outer diameter. Outer diameter as, you know, DO. And what is the value of that? It is 250 mm. And what is inner diameter? DI. Let me write that as DI, inner diameter, that is 230 mm. And the value of acceleration due to gravity is G is generally 9.81, but he has given 10 meter per second square. Fine. And if G factor is the ratio of centrifugal force to the weight of shift, he has given already, the formula also has been given. It's very simple question actually. I don't know why he has asked this question. So what he's saying that G factor is nothing but a ratio of centrifugal force divided by the weight. And he told that that is 60. That is given. And he's asking what is the rotational speed N? That is N is equal to how much? That is what is the question. In RPM he's asking. Okay. So now we have to find this centrifugal force and the weight. So let's say this centrifugal, let me write in different things to differentiate what is not given. So let's write G factor as this. What is centrifugal force? MR omega square. M R omega square divided by what is the weight? Weight is mass times gravity. Right? And what is R? Here we have been given this two, di and d naught. So obviously, as the centrifugal casting is performed, so we have to take the maximum, right? So obviously, this will be the value of R. So that is R is equal to d naught by 2. So R is equal to how much? 250 mm by 2. That is 125 mm. Okay. Since G is given in meters per second, let's write this R also in terms of meters. So if you want to write that in meters, it is 0.125 meters. If you're converting mm to meters, right? So let's find out this mass gets cancelled. R is there, omega we have to see. And what is omega? Omega is nothing but 2 pi n by 60. Right? Omega is angular velocity and R is the number of rotations or rotations per minute, RPM. RPM. This is RPM. Right? So let's substitute. What is G factor given? G factor given as 60. And what is R? R is 0.125 into omega square. So it is 2 into pi into n divided by 60 whole square divided by acceleration due to gravity, that is 10, because 10 has been here. So from here we have all the values here, and we have to find out the value of n. N is nothing but 661 point. After calculating, you'll get as 661.6 rpm. Okay, fine. So here what we can say is that the answer is varying from what you say in solution part. The answer is varying from 660, when the key, whatever the gate key that they're given is this. So obviously this is falling in this. So the answer is 661 rpm. Okay, fine. Let's move to the next question. So let me write the answer here, that is 661.6 rpm. Okay, fine. Let's move to the next question. The resistance spot welding of 1.2 1.5 mm thick metal sheets is performed using welding current of 10,000 amperes for 0.25 seconds. Again, every time we have to write what is given. Let's write what is given. The thickness of two sheets. Let's write the thickness. Thickness T is given as what? Or I can write thickness like this, because time and thickness will be having some problem. So let's write thickness is equal to 1.55 meters mm, and is performed by using current I is 10,000 amperes, right? And what is the time? Time T is 0.25 seconds. Okay. The contact resistance at the interface of metal sheets is 0.001 ohms. Okay, so R resistance is nothing but 0.00030, right? 301 ohms. Okay, the voltage of weld nugget formed after the welding is volume. So now not voltage, volume. Volume of the nugget formed after the welding is 70 mm cube. So let's write volume of nugget is Vn. Let's assume that is 70 mm cube. Considering the heat required to melt unit volume. So he's asking for melting unit volume, what is the heat required? Okay, so let's write heat energy required to melt 1 or unit volume. Okay, so that is how much he's saying. He's saying it is 12 joule per mm cube. For 1 mm cube, he needs 12 joules. 1 mm cube of volume, he needs 12 joules of heat energy to melt, right? So he's asking what is the thermal efficiency of the welding process. It's a spot welding. Obviously, how is spot welding done? So you have two, spot welding torches like this, and two sheets of some thickness. Here it is 1.55 mm, and there is another this thing, right? This is fixed. So fine. Here we can see the nugget formed. This is what called nugget. This is asking what is the thermal efficiency. So we already know the thermal efficiency formula as eta m is equal to thermal efficiency eta m is equal to heat utilized by heat supplied or energy supplied or heat energy supplied, you can say. Okay, fine. So we have to find this. So first we have to find what is heat utilized. So let's what is heat utilized? This heat utilized, this whatever the heat is utilized is for melting, right? For melting, right? Let's denote that as HM, heat melting, and this as HS, heat supplied. So what is HM? So what he's saying here, he's saying that I am providing what is the volume of nugget? So obviously the nugget volume is VM here, right? So he's saying 12 joule of energy, heat energy is required for melting 1 mm cube. For 70 mm cube, how much? 12 into 70, right? So HM can be written as 12 into 70, right? Why? So for 1 mm cube, you require 12 joules, right? So for 70 mm cube, how much you want? Obviously, it is 12 into 70 heat energy, right? So this gives 840 joules heat of melting, that is heat utilized, and heat supplied is nothing but is given as this joule heating, that is I square RT. What is I? I is nothing but 10,000 square, and R is 0.0001 and time is 0.25 seconds, right? And this gives as 2500 joules, 2500 joules. Now obviously you can use that melting efficiency formula, that is heat supplied, heat melting by heat supplied, or heat utilized by heat supplied is nothing but this, that is 840. He's asking in percentage, right? So obviously we have to multiply this with 100. Into 100 is 840 divided by 2500 into 100. Sorry, 100, not 1000. Okay. So melting efficiency, whatever this is given as 33.6 after calculating. So the answer is this, 33.6% of, so he's selling rounded to 1 decimal. So that's why you have rounded out to 1 decimal, that is 33.6%. That is the heat efficiency. Okay, fine. Fine, let's go to the next question. In this question, he has asked from the machining part, that is, an orthogonal cutting operation is performed using a single point cutting tool with a rake angle of 12 degrees on a lathe. He is doing it on a lathe. During turning, the cutting force, and okay, let's write what is given while reading the question. Fine, let's write what is given. Given. What is given? The orthogonal cutting operation is performed using single cutting point, and the rake angle is given as 12 degrees. The rake angle alpha is given as 12 degrees. During turning, the cutting force and the friction force are given as, the cutting force I can write as FC, and friction force I'll write as F. That's it, right? This is your friction force. Cutting force is how much? 1000 newtons. Friction force is 600 newtons. Okay. If the chip thickness and uncut chip thickness during the turning are, so he has given T1 and T2, right? How much is this? T1 is how much? 1.5 mm chip thickness. Uncut chip thickness is how much? 0.75. Okay, I think we are writing it ulta. Let's write, because first it comes uncut chip thickness. T1 is uncut chip thickness, that is 0.75 mm, and this is 0. Okay, and now he's asking what is the shear force. Fs is equal to question mark. We don't know that, right? So obviously, as we are dealing with the cutting forces, we'll be dealing with the merchant circle diagram, right? So let's use the merchant circle diagram to find out the shear force. Okay, let's draw the merchant circle diagram. So this is your, circle, and let me draw. This is your planes, perpendicular planes, right? And this is where your cutting tool is there, and this is tool, cutting tool, right? And we can extend this as, sorry, as your friction plane, a friction surface. This is your friction, line, right? And perpendicular, perpendicular to the, sorry, this is not friction line. Let me write down again. Sorry for this. So this is your friction surface, right? This is your friction because this is your rake, right? Rake surface. Obviously, this is your friction, right? This is your F, friction force. And perpendicular to that friction force, we have normal force, right? This is your normal force. And both are having a resultant one, that is your resultant force. This is your R, that is resultant, right? And what do we have? We have cutting force in this direction. So this is your cutting force. This is FC, cutting force. And perpendicular to that, we have thrust force. This is FT, right? And there is another thing, that is shear plane. So let's draw the shear plane also. This is your shear force, and perpendicular to that, we have the force that is perpendicular to shear force, that is FSN, right? So now let's put the angles and see. So what are the angles? So obviously here it is alpha, so this is alpha, and we know this is phi, right? And we know this angle, the angle between the resultant and the normal force, that is beta. What is that? Beta, it is friction angle, right? And as this is alpha, and what is this angle here? This angle will be here by calculation, that is beta minus alpha. Okay, let me write that clearly. This is beta minus alpha. Okay, so now with these angles, we can write the equation, right? How do you write that equation? So R, okay, let me write in a different ink. R, resultant force, can be written as F pi sine beta. How? Right, if you take this triangle, so F and R and beta is there here, and this is your right angle triangle, right? So if you want to write sine beta will be F by R, right? So if you can convert that, R is equal to F by sine beta, like that. We can keep on writing, considering different triangles as this. This is by N by cos beta, sorry. Cos beta, by considering this triangle, by considering O, A, B. Okay, and by considering another triangle, that is OB C, let's say OBC, OBC, OCB triangle. If you're considering OCB triangle, then you can write as FT by sine beta minus alpha, that is equal to FC by cos beta minus alpha, right? Similarly, if you're considering triangle ODB, OD and B, okay, resultant is common. I can write as FSN by sine, that is 5 plus beta minus alpha, right? The total angle is 5 plus beta minus alpha. So 5 plus beta minus alpha. And here another one is Fs as cos 5 plus beta minus alpha. Okay, fine. So now that we have this relation, so what are given? We know Fc. So what are given? What are known here? We know Fc, right? We know F, and we are supposed to find this Fs, right? So let's relate this any of these three equations. Any we have three terms here: F by sin beta, Fc by cos beta minus alpha, Fs by cos 5 plus beta minus alpha. Let's equate any of the two and get the answer. So for requiring this, we need to have the value of what do you say, the 5, because here 5 is there. Fs, no, F5 we have to have. So to what is 5? 5 is nothing but shear angle, right? So we have to find out that. So let's find that. R is equal to T1 by T2. This is chip thickness ratio, right? This is 0.75 divided by, why R is required? Because tan phi is equal to R cos alpha by 1 minus R sin alpha, right? So that's the reason why we need R. R is chip thickness ratio. So how much is this? This is nothing but 0.5. So tan phi is equal to R cos alpha by 1 minus R sin alpha. For this, we need R. That's the reason why I've calculated R. R is 0.5 into cos alpha. What is the alpha value? That is 12 degrees divided by 1 minus 0.5 into sin alpha. That is 12 degrees. So if you're doing the inverse of the tan, you get phi value as 28.63 degrees. Calculate this value and inverse tan, you'll get 5. So once you get 5, you is the value of beta given? Obviously, he has not given the value of beta. So what you have to do, first you have to find the value of beta. So let's equate F and this. Let's equate this. Okay, let's equate this. So what is this? If you're equating that, F by sine beta is equal to Fc by cos beta minus alpha, to find the value of beta. That's what I'm doing this. So what is F? 1000, and by sine beta is equal to Fc. What is Fc? Fc is 1000. Sorry, 600 is F, right? So sorry. $600, right? And what is Fc? That is 1000. That equals divided by cos beta minus 12. Right? Now in this we have beta as unknown, right? So what is that? We'll expand that. So here we have 600 by 1000 is equal to sine beta by cos beta minus 10. We'll write like that. Okay, 600 by 1000 is equal to, how much is this? Sine beta by cos beta minus 12, right? Sine beta by cos beta minus 12. Okay, so how much is this? This is 0.6 into, let's expand cos beta minus 12. How much is that? Cos beta, cos A minus B is cos A plus cos A, cos B plus cos A, cos sin A, sin B, right? So cos 12 plus sin A, sin B, sin beta, sin 12, right? Sin 12 degrees. This is equal to sin beta, right? Now what we have to do is that we will take the the value of cos beta sin beta common, that is 0.6 into cos beta into cos 12 is equal to, let's take sin beta common. Sin beta, if you're taking common, how much is this? That is nothing but 1 minus 0.6 into sin 12, right? This is what we'll get, right? And if you're calculating the values of this 0.6 into cos 12 and 1 minus 0.6 into sin beta, let's see, 0.6 into cos 12 is nothing but 0.5868 into cos beta is equal to sin beta into the value of that is 0.8752, like this you'll get. Okay, and then you divide sin beta by cos beta, sin beta by cos. So tan beta is equal to, what is the answer? 0.5868 divided by 0.8752. So if you're inverting, you get beta as nothing but 33.84 degrees. That's it. Finished. Now you got the value of phi, you got the value of beta. Now equate any of the equations, right? So how can you equate this thing? You can equate sin beta, f by sin beta is equal to this thing. So let's equate this two. Let's equate this two. Okay, let's write that. F by sin beta is equal to fs by cos phi plus beta minus alpha. Cos phi plus beta minus alpha, right? So we know the values of f. What is the value of f? F is nothing but 600. 600 divided by sin beta. Sin beta, we know the value of beta, that is 33.84 degrees, is equal to, we don't know value of fs, that's what we have to try and find. And cos, what is the value of phi? Phi is nothing but 28.63, right? 28.63 plus beta is 33.84 minus 12, right? And if you are trying to calculate all these things, you want to find, you calculate the value of sin 33.84 and cos 28.63 plus 33.84 minus 12, you calculate the cos of that value, and if you are multiplying and you're getting the value as 685.77 newtons, and this is the answer. Okay, 685.77 newtons, that is the answer. Okay, so that is the solution for this nice question. It's lengthy, but it's very simple. If you know how to draw the measurement circle diagram, it's very easy. See what are not available and try to equate them and get what are not available, and then after getting what are not available like beta, substitute back into these equations. It's very easy questions. Okay, guys.